Section 3.2, Conditional Probability and the Multiplication Rule. Let's begin with the definition of conditional probability. A conditional probability is the probability of an event occurring given that the other event has already occurred. The conditional probability of event B occurring given that the event A has occurred is denoted as B, P, B, A, and it's read as probability of B given A. Example 1. Two cards are selected in sequence from a standard deck of 52 playing cards. Find the probability that the second card is queen, given that the first card is a king. Assume the king is not replaced. All right, so we have we have two options to consider. The first one is find the probability that the first card is a king. Okay, so we have 52 playing cards, and we have 4 cards that could be king. Now for our second probability, if we picked one card and we still happen to get a king, then we don't have 52 cards anymore. We have 51. Now for our second card, we want to find the probability of a queen. Okay, there's 4 cards that are queen. So then I multiply them. 4 times 4 is 16. 52 times 51 is 2,652. We divide it and we round so that we have 0.006 as our answer. Definition of independent and dependent events. Two events are independent when the occurrence of one of the events does not affect the probability of the occurrence of the other event. Two events A and B are independent when the events are not. Two events A and B are independent, then probability of B and A equal the probability of B, or when the probability of A then B equals PA. Events that are not independent are said to be dependent. So if one way of putting it is if it affects the other one as a result, then it is dependent. Let's take a look at these examples to help us think about what it means to be dependent and independent. 2. Example 2. Determine whether the events are independent or dependent. 1. Selecting a king from a standard deck of 52 playing cards, not replacing it, and then selecting a queen from the deck. So like our first example. Okay, well, I'm not putting it back. And so it affects the cards that are in play. So because of this, this would be considered dependent. Where the probability of getting a king is 4 out of 52, and the probability of getting a queen after a king would be 4 out of not 52 but 51 because I didn't put it back. 2. Tossing a coin and getting a head, and then rolling a 6-sided die and obtaining a 6. Well, one outcome does not affect the other, right? Because they're two different things. A coin toss that isn't related to a roll die. So because of this, they're independent. 3, driving over 85 miles per hour and then getting in a car accident. While speed is a relative indicator of, or increases the probability of getting an accident, this would be dependent. And I know this one can be argued, but this is what we're going for this one. All right. In this table, it gives us a multiplication rule of two events, just so we have them handy. So if they're dependent, it's A times the two probabilities together, and if they're independent, we just multiply the two probabilities separately without worrying about what the other one is doing, how it's affecting it. Example 3. We have that first problem again. Two cards are selected without replacing the first card from a standard deck of 52 playing cards. Find the probability of selecting a king and then selecting a queen. Just like our very first example. So we did this one already. The probability of getting a king and a queen. That gives us, well, we have to consider the probability of getting a king times the probability of getting a queen after a king. So that we have 4 out of 52 times 4 out of 51, which is 16 over 2,652. If we punch this in the calculator, it is about 0.006. 2. Rolling a coin. Rolling a coin. A coin is tossed and a die is rolled. Find the probability of tossing a head and then rolling a 6. Okay, so for this one, we want the probability of H and 6. Looking ahead and getting a 6. Okay, well, probability of getting ahead, that's going to be 1 out of 2, times the probability of getting a 6, that's going to be 1 out of 6. We multiply them, and our answer is 1 out of 12. We want the decimal answers, so we punch into our calculator 1 divided by 12, and that gives us 0.083. Note, these past questions, you want to ask yourself if what you took from the first time affects the other one's outcome. So that's what I'm looking at when you're thinking about dependent or dependent. Okay, so for the next set of questions, recall the definition of a complement from our previous section 3.1. Definition: complement of event. The complement of event B is a set of all outcomes in a sample space that are not included in event E. The complement of event E is noted as E prime. And we have a Venn diagram that we use, right? So if all of this is our event space, and this is E, then you have E and not E, right? So everything else. Also, you'll see this a lot. A phrase you will see quite often is at least once. In order to make this calculation possible, use a complement. So ignore the at least once, find your probability, find your answer. So find answer without at least once. At least once. And then second, you'll get your answer. Subtract your answer from 1. So 1 minus your answer. That will give you the probability of at least once from whatever you're calculating. We'll see this in an example, so you'll make more sense of my chicken scratch above. Example 4. An ulterior cruciate alignment, ACL, reconstructive surgery for an ACL surgery, the probability that the surgery is successful is 0.95, so 95%. One, find the probability that the 3 ACL surgeries are successful. Okay, for all 3 to be successful, well, success is 95. So maybe we should start off by saying that. Success is 95. So therefore, failure or not success will be the opposite, or prime. So it'll be 1 minus 0.95, 0.05. Okay, to answer 1, the probability of 3 successes, well, we multiply them. 0.95 times 0.95 times 0.95. Or you can also write it as 0.95 raised to the third power. And that gives us about 0.857. 2. Find the probability that none of the 3 are successful. Okay, failure or not success, we said was 1 minus 0.95, so 0.05. So 3 failures multiplied would give us 0.05 times 0.05 times 0.05. Okay, we multiply them and we'll get, okay, so this is the way you'll see it in your calculator. You'll get 125, I'm sorry, wrote the decimal wrong. 1.25, you'll get an E negative 4. So it's giving you its scientific notation. Because you have a negative, you have to take your decimal and move it to the left. So you're moving it left 4 spaces. So that you have 1, 2, 3, 4, and that's your new decimal. Every empty space is a 0. So really this is 0.000125. Also, if this were a positive, then you move your decimal to the right. It just means a really big number. All right, so we have our answers for 1, 2, now for 3. Find the probability that at least one of the ACL surgery is successful. So we see that phrase, at least one. At least one. So we're talking that at least one of the 3 are successful from our failures. So we have our answer for our failures. So we do 1 minus. 1 minus 0.00125. And our answer is 0.999. All right, that's it for this section. If you want more practice, you can always check out the problems at the end of the section. Um, they're pretty fun problems. I like them. All right, that's it for section 3.2, conditional probability and the multiplication rule. Thank you.